Okay. Compound types. So earlier they said they were mentioning scalar types and compound types, if I remember correctly. So a compound type can group multiple values into one type. Rust has two primitive compound types, tuples and arrays. So the tuple type. A tuple is a general way of grouping together some number of other values with a variety of types into one compound type. Tuples have a fixed length. Once declared, they cannot grow or shrink in size. We create a tuple by writing a comma-separated list of values inside parentheses, and each position in a tuple has a type, and the types of the different values in the tuple don't have to be the same. We've added optional type annotations in the example. So here's their example, right? Let's get rid of this. We have let tup. They have the type annotations, but let's see if we can get away with not writing those. 500, 6.4, 1. It's supposed to be a comma. And as you see, once I have the syntax correct, the annotation, what it should be, is right there. I can explicitly write that, or I can just let the editor infer that, the language infer that. The variable tup binds to the entire tuple because a tuple is considered a single compound element. To get the individual values out of the tuple, we can use a pattern matching to destructure a tuple value like this. So they're saying one way that we could assign these things outside of the tuple, just get them out, is let's say x, y, z, right? And that's just going to be equal to tup, because our tuple has 3 values. So when they're coming out, x is going to go to this one, y is going to go to this one, z is going to go to this one. Makes sense. And then for kicks, they have the print line. Print the value of y. The value of y is comma y 6.4, just like we were saying earlier. That is called destructuring. Just to be able to take to unpack, let's say, this tuple. In addition to destructuring, through pattern matching, we can access a tuple element directly by using the dot, by using a period or dot followed by the index of the value that we want. So another way we could have gone about doing this is the first value is 500, right? So let's say let 500 equal, well, they have x there. We can change this to x. Make it. I think it's more explicit as tuple. I'm gonna leave it as tuple. Tup dot 0, right? Okay, and then we can do 6.4. Let 6.4 equal tup dot 1, and we can do let 1 equal tup dot 2. So as you can see, we just have the dot or period and then the index. Index always starts at 0, so we have this is the 0 place, this is the 1 place, and this is the 2 place. And we're just distributing them as they are laid out. So the next type they go over called arrays, or the array type. Another way to have a collection of multiple values is with an array. Unlike a tuple, every element of an array must have the same type. So as you saw over here with the tuple, we have 2 different types. Not 3, just 2. We have I32 and we have F64, which is a signed 32-bit and a floating point number that is 64-bit. However, with arrays, everything within the array has to be the same type. Arrays in Rust are different from arrays in other languages because arrays in Rust have a fixed length, like tuples. Okay? In Rust, the values going into an array are written as a comma separated list. So let's write one of those. Let A equal 1, 2, 3, 4, 5. And I should probably put spaces in there. I was just typing them really fast. 3, 4, 5. And as you see, the annotation is right here. It looks like it is a signed 32-bit with length 5. Arrays are useful when you want your data allocated on the stack rather than the heap. Okay, so stacks and heap are, I can go to those concepts now, I can go to them later, you can look them up, but as of right now, they're not all that important. They're just two different little places that memory is stored. One is of a fixed size, it's easier to get at, and one can be as a pointer to a piece of memory that, to the start point of a piece of memory, you can still grow. A vector is a similar collection type provided by the standard library that is allowed to grow or shrink in size. If you're unsure whether to use an array or a vector, you should probably use a vector. Okay? An example of when you might want to use an array rather than a vector is in a program that needs to know the name of the month of the year. It is very unlikely that such a program will need to add or remove months, so you can use an array to define them. Yeah, because you know there's only going to be 12 months in a year. That's fine. And if you want to define them explicitly, you have the annotation types. We have the type and then you have the length. Now, the next section is going over how to access elements within an array. So we have this array in front of us with A, 1 through 5, and let's say we want to get to the first element. First, we can say A, square brackets, index. 0 is the first index, as indexes start at 0. And we can do the second index. And we can keep going, right? Second index equals to a 1. That's fine. But you do have concepts of invalid index. So we know that for A only goes through 1 through 5. So we have 0, 1, 2, 3, 4. But what happens if we try to access index 10? Well, let's see. Let index equal 10. Let element equal A at index. Print line, the value of element is so just to be clear, as we're going through this right now, the compiler can't tell us there's an issue. This is going to be a runtime issue. What I mean by runtime issue is that this is the type of issue that you can only discover while the program is running. And as you can see here, down here after we ran it, we have an issue. Index out of bounds. The length is 5, but the index is 10. And that concludes the end of this section. Hope you guys enjoyed it. Hope it was useful. Thank you for watching. Peace.